Namaste to all. Welcome to my channel MA Tuitions. I am Lita. Today we are going to discuss the chapter 1 real numbers, a new topic. Don't forget to like, share and subscribe my channel and just put the bell button, okay? If you are watching my channel for the first time, please go through the previous sections. I will give the link on the description box, okay? Let me continue with the new topic. You have already studied about prime numbers and composite numbers, isn't it? What are the prime numbers and what does it mean? Prime numbers means the numbers which have only two factors, that is the number itself and the 1, isn't it? And what are composite numbers? Composite numbers are those which have more than two factors. I will show you some examples. You have heard about the prime numbers. The prime numbers are 2, 3, 5, 7, 11, etc. What is the common feature of these numbers? All these numbers have only two factors. That means 2 have two factors, 1 and 2. Only 1 into 2 is 2. Am I right? If you are writing 3, 3 has only two factors, that is 1 and 3. That means 1 into 3 is 3. Whatever may be the number in prime numbers, it has only two factors. That means 1 and the number itself. That means if you are taking 11, it will be 1 into 11, 11. Okay, that you know well. We will move on to the composite numbers. I am writing the composite number 4. The smallest composite number is 4. So 4 can be written as 1 into 4, 4 and 2 into 2, 4. Am I right? So there are three factors, 1, 2 and 4. So it's a composite number. If you are taking 6, you will get 1 into 6, 6 and 2 into 3, 6. There are 4 factors, 1, 2, 3 and 6. So these are the composite numbers. These you have already studied in your smaller classes. Then why we are discussing all these things now? Any guesses? Okay, I will tell you. There is a theorem. It is fundamental theorem of arithmetics. Have you heard about that? Fundamental theorem of arithmetics. Fundamental theorem of arithmetics. It states that every composite number can be written as a product of prime numbers. And it is unique. What is that? Every composite number can be written as a product of prime numbers and it is unique. Sometimes the order may change, but it is unique. I will explain with an example. Okay. Let's take 24. You know that 24 is a composite number. So 24 can be written as the product of prime numbers. 24 may be written as 24 divided by 2. It is 12. Again divided by 2. 6. 2. Again 3. 2. 1. This may be also written like this as a factor tree that you have already studied. That is just like 24. It can be divided by 2. Then you will get here the 12 and again the 2. Then you will get 6. Again here 2 and 3. Both are right. This is a factor tree and this is just as a prime factorization. Okay. So 24 can be written as 2 into 2 into 2 into, here it is 3. No other number is there to divide 3, no? So we can write 24 as 2 into 2 into 2 into 3. So this is the prime factorization of 24. Someone may do like this. 24 may be divided with 3. Then he will get 8. And then again 2, 4, 2, 2, 2, 1. Here also the answer is 3 into 2 into 2 into 2 into 1. But both are unique. The order changed but all the numbers are the same. 2, 2, 2, 3. 3 to, that means 2 raised to 3 into 3. 3 times 2 and 1 times 3. Here also 1 times 3 and 3 times 2. Both are same. So every composite number can be written as a product of prime numbers and it will be a unique one. Sometimes the order may change. One example. Consider the number 4 raised to n where n is a natural number. Check whether there is any value of n for which 4 raised to n ends with the digit 0. So what is the meaning of this question? We had given a number which is 4 raised to n. When we are giving natural numbers to this n, we will get the corresponding terms. So if you are taking n as 1, we will get 4 raised to 1, that is 4. Then if you are giving 2, you will get 16. Then 4 raised to 3, it will be 64, just like that is going. Okay, we want to find that if you are writing like this, can you find any one term which ends in 0? Which means just like 10, 20, 30, 40, etc. Okay, can you find any multiple of 10 in this sequence? That is the question. So you know that if you are finding any multiple of 10, it should be a multiple of 2 and 5, since 10 can be written as 2 into 5. Isn't it? 10 can be written as 2 into 5. Then if you are finding any number ending with 0 in this sequence, it must also divisible by this 2 and 5. Then only you will get 10 as a factor. Okay. Now coming to this 4 raised to n. 4 raised to n can be written as 4 can be written as 2 into 2. That's whole raised to n. This can be written as 2 raised to 2 whole raised to n. 2 times 2, that means 2 raised to 2. That is 2 raised to 2n. X raised to m whole raised to n can be written as x raised to mn, that you have studied in exponents. Okay. So here the only one factor of this 4 raised to n is 2. The only factor is 2. Here we need 2 and 5. So this 5 is missing here. So we cannot say that this 4 raised to n is a multiple of this 10. Or in other words, we can say that in this sequence or in this 4 raised to n, no any number which ends in 0. Okay, any number we cannot find which ends in the digit 0. Got it? So we are going to write the proof of that question, that we have given 4 raised to n, which can be written as 2 into 2 whole raised to n, which can be written as 2 raised to 2 whole raised to n, which is 2 raised to 2n. This we will prove in a contradiction method. First we will take that this 4 raised to n is a multiple of 10. Multiple of 10. Okay. Then only you will find any number with which ends in a digit 0. Okay. Then only we can find a number with 0. So if this is a multiple of 10, surely it is a multiple of 2 and 5. 4 raised to n must be a multiple of 2 and 5. Reason is that since 10 equal to 2 into 5. Okay, since 10 is a multiple of 2 and both 2 and 5, then you have to find some number which is a multiple of 2 and 5. So this is not possible. Not possible. What is the reason? We have already found that 4 raised to n is a multiple of only 2. Since 4 raised to n equal to 2 raised to 2n. So this is a contradiction method. So we can say that no any number is there with n which ending in 0. Next question. Find the Lcm and Hcf of 6 and 20 by prime factorization method. So you know how to prime factorize this 6 and 20. I will do like this. 6 divided by 2 you will get 3. 3 again with 3 and 1. So 6 can be written as 2 into 3. And also 20 as 2, 10. Then again 2, 5. Then again 5, 1. So it will be 20 is like this, 2 into 5. This can be also written like this, 2 raised to 2 into 5. Am I right? So how can you find out this LCM and HCF? HCF, you know the highest common factor. The highest, it will be the largest one. And it should be a common factor. So here only 2 is the common factor to both 6 and 20. Only 2 is there which is common to 6 and 20. So we can write HCF as 2. And what about LCM? Take 2 raised to 2. 2 is common to both 6 and 20. And here the largest one is 2 raised to 2. Here only 2 is there. Here 2 raised to 2 is there. So we can take this 2 raised to 2. And here it is 5. So we can take this 5. 20 is a multiple of 5. And here 3. 6 is a multiple of 3. So we can take this both 3 and 5 and this 2 raised to 2. So you will get 4 into 5 into 3 and it is 60. So we will get the LCM as 60. So how can you define this HCF and LCM? HCF is the smallest, is the product of, that just like that we can write, product of smallest powers, smallest common powers of common factors. Once more, HCF is the product of smallest powers of the common factor. In these two numbers, here also 2 is there, here also 2 is there. 3 is not common to both and 5 also is not common to both. So we cannot take this 3 and 5 in when we are finding this HCF. So we can take only this 2. Here also 2, here also 2 is there. So we can take this 2 as the HCF. That's why we are telling that smallest power of common factor. It should be common factor. 2 is a factor of 6 and 2 is a factor of 20. So we can take this 2 only. And what about LCM? LCM is the largest or greatest power of the product of largest power of or greatest power of the prime factors involved in each number. Got it? How many numbers may be there? We have to find out the largest prime factors or the power of the largest prime factors. In this 6, we have only 2 and 3. In 20, you have 2 2s and 1 5. That means the highest power. Here also 2 is there, here also 2 is there. In both the cases, which is the larger one, 2 raised to 2. So we are taking 2 raised to 2. So here is a 5, but here we cannot find any 5. Then no problem is there. The highest power of 5 is 5 itself. So we can use this 5. Here 3 is a factor of 6, but 3 is not a factor of 20. When we are finding LCM, there is no problem if both the factors are there for both the numbers. If it is only once happening, no problem. You can take this 3. Here we cannot find 3. Then also we can take this 3 as for finding the LCM. So we will take 4 into 5 into 3. Just like that we are getting 60. Understood? So once again, HCF is the product of smallest powers of the common factor. Smallest powers. And LCM is the product of largest powers which contains product of largest powers of the prime factors involved in each number. Whatever may be the numbers, in each number how many prime factors are there or which power is the highest one, that we have to take for the LCM. The last question we have discussed about 6 and 20. Find out the LCM and HCF of 6 and 20. We got just like this, LCM as 60 and HCF as 2. Do you find a relation between the numbers and LCM and HCF? There is a relation. 6 into 20. This is the product of numbers. Product of numbers. Product of numbers is 6 into 20, that is 120. Okay. And what about the product of LCM and HCF? Here LCM and HCF, the product of LCM and HCM, 60 into 2 equal to 120. Both are same. Okay. So there is a concept which leads to this, that is the product of two numbers. Product of two numbers is equal to the LCM and LCM of the numbers and the HCF of the numbers. Okay, product of two numbers is equal to the product of LCM and HCF. So generally we can write like this. If we are taking A and B as the two numbers, then the product of A and B, that means A into B, or we can say write like this AB, which is equal to LCM of A and B into HCF of A and B. Got it? You have to study this formula to find our solutions and all. Okay, so here I told you like that. Whenever you are getting two numbers, the product of that two numbers will be equal to the product of their LCM and their HCF. Next question, find the HCF of 96 and 404 by Prime Factorization method and hence find their LCM. We want to find out the HCF of 96 and 404 using this Prime Factorization method, and we have to find out from that the LCM. Okay, no need to do the Prime Factorization. We want to use that formula we have studied that just now, no? That is the product of the numbers is equal to the LCM into HCF. Okay, so we will continue by doing Prime Factorization to both 96 and 404. First we will do 96. 96 will be divided by 2, means you will get 4 into 2, 8. 8 into 2, 16. Again 2, it will be 24. 2, 1 time 2. Then 6 times 12. 3 times again 3 and 1. So we can write 96 as 2 raised to 5 into 3. Okay. Next we will do the Prime Factorization for 404. So it is 404 divided by 2, you will get 202, again by 2 it will be 101. So we can write 101 is a prime factor. So we cannot find any factor for this 101. So we have to just stop here and write 2 raised to 2, 2 times 2 and 101. So to find out the HCF, here 2 raised to 2 is there and 101 is there, and here 3 and 101 is not common to both. Only 2 is the common factor for 196 and 404. And the maximum and the minimum common factor is 2 raised to 2. Here also 2 raised to 2 is there. Here also 2 raised to 2 is there. So we can take this as 2 raised to 2. That means 4 is the HCF. Now we want to find out the LCM. Okay. How we can find this LCM? We know that LCM into HCF equal to the product of numbers. Isn't it? Product of numbers. So we'll write LCM into HCF is 4 and product of numbers means here it will be 96 into 404. Now we will take this 4 to that side. It will 96 into 404 by 4. So when you are cutting with this 4, it will be 101. You will get 9696 by multiplying. So we will get the LCM as 9696. It's very simple, you know. Okay. Next question. Find the HCF and LCM of 6, 72 and 120. Okay. So we will find out through Prime Factorization method. I'll just write 6 and 2 times. It will be 3 and 3 times 1. So 6 can be written as 2 into 3. No need to find like this. Then 72. 72 can be written like this. 2, 36. Then again 2. It will be 18, 2, 9 times again with 3 times. Then you will get 2 raised to 1, 2, 3. 2 raised to 3 into 3 raised to 2. Okay. Then 120. 120 with 2, it will be 6, 60. Then again 30, 2, 15. Now we can divide with 5 or 3. So it will be 3, 3, 1. So here 120 can be written like this. 2 raised to 3 into 5 into 3. So what is the HCF? HCF. 2 is common to these 3 numbers. Here also 2, here is 2, here is 2. So we can take this 2. And 3 is also common. So we can take this 3. So our HCF is 6. Finished. Now how can you find out LCM? Here 2, a factor is 2. So we can take the largest power of 2. So it is 2 raised to 3. And 5 is also there. So we can find 5 raised to 1 is there. This is the largest one. No other number contains the factors 5. And what about 3? In 72 only we can find out the largest one. So we will take 3 raised to 2. So you will get 8 into 5 into 9. So you will get 360 as the LCM. Okay, 360 will be your LCM. Move on to the exercise 1.2. The first question, express each of the following as a product of prime numbers. So there are 5 questions. I have already written 1 and 2. So we will do 140 can be written as 140 will be divided by 2. Then you will get 70. Isn't it? 14 into 2 for 7 times it will go 70. Again with 2 you will get 35. Then with 5 you will find 7. Then again 7, 1. So 140 can be written like this. 2, it is 2 times 2 is there. So you can write 2 raised to 2. Then into 5 into 7. It's a very simple question. Then next 156. How can you write this 156? 156 can be written by just like this. Divided by 2 you will get 7 into 2 14, 8 into 2 16. Then again 2, 3 into 2 6, 9 into 2 18. Then with 3. So it will go 13 times. And again with 13 you will get 1 here. So we can write it is 2 times 2 is there. 2 raised to 2 into 3 into 13. Okay. We'll do the next question 3825. Just divide 3825 with 5. 7 times 35. Then it will be 35, 32, 6 times 5, 30, then 25, 5 times 5, 25. Okay. Now again with 5, 1 time 5 is 5, 26, then it will be 5 into 5, 25, and it is 15, 3 times 15. This is not divisible by 5, but it is divisible by 1 plus 5 plus 3 is 5 plus 1, 6 plus 3, 9. It is divisible by 3. That means 153 also divisible by 3. So we can use here 3. 5 times 3 is 50 and 1 times 3 is 3. Here also 51. 5 plus 1 is 6. 6 is a multiple of 3. So here also we can divide with a 3. So we will get 1 times 3 and 21, 70. This is a prime number that you know. 17 is a prime number. So there is no any factor for this 17. It only divides with 17 and gives 1. So we can write 2 times 5 is there. So we can write 5 raised to 2. And 2 times 3 is there. That means 3 raised to 2. And only 1 times 17. So into 17. This is the prime factorization of 3825. Okay. Now move on to the next question 5005. We will divide this 5005 with 5. We will get 1, 0, 0 and 1. Then it is not divisible by 5, 2, 3, 4 and all, only divisible by 7. 7. Okay. So when divided by 7, 1 times 7 it will go 7, then 30, 7 into 4, 28, then 21 will come, 143 is there. Okay, 143 is also divisible by 11. Okay, 11 into 13 is 143. So 13 is also a prime number. No need to divide any much. So you can write this 5005 as 5 into 7 into 11 into 30. All prime factors. Okay, 5005 can be written as 5 into 7 into 11 into 30. Okay. Next 7429. It's just 7429. It will go in only 17. Okay, 17 you will get 437. 437. Then again divide with, it will go on 19. Okay, 19. Then you will get 23. If this is difficult to you, then you just divide with 7429 by 17. As usual you divide. Okay. Then here we can write this 7429 as 17 into 19 into 23. Got it? We will continue the exercise 1.2 in the next section. If you are finding any difficulties in my classes, please mention in my comment box. Don't forget to like, share and subscribe. We will meet you on the next section. Thank you so much for watching my videos.